Ready and go. So here's this circle then. It's got a centrally symmetrical cross of width √2, leaving these four corner pieces of side 1. What are the areas of the four corners together? Well, the first thing you notice is 1 √2, because if those are two sides of a triangle, which must be at right angles because of the symmetry, then this side must be √2. And straight away that means you've got an octagon here. Because if that's √2 and this is √2, then you've got 8 equally spaced sides of √2. So you could find the area of these from the areas of this segment added on to the area of this triangle and then times 4. You could do it that way because you could get the area of this segment from the area of the circle minus the area of the octagon. And the octagon's straightforward enough because it's just a big square with these four corners cut off. But I think I'll do it by considering this sector here, because you know that that sector is going to be 1/8 of the circle. So the area of that corner piece will be the difference between the area of the sector and the area of this shape here. Now you could find the area of this part by splitting it again, but you don't need to, because you know that shape. That's a kite. It's a delta kite. So area of the sector first. Well, area of the sector will be 1/8 of the circle. So I'll do that first of all. Area of that sector is going to be 1/8 of the area of the circle, so that'd be pi r squared. But it'd actually be easier just to find the diameter because I know these two sides. So instead of r squared, I'll make it d upon 2 all squared, which is pi d squared upon 4. But that means I'll need to know the diameter squared, luckily, so I don't need to do any square roots. Well, the diameter will be the distance from this corner to this corner, so that would come from this triangle then. So the width of it is √2, and this distance is 1 plus √2 plus another 1, which is 2 plus √2. So the diameter squared will be 2 plus √2 squared plus another √2 squared. Well, that'll just be square the first, square the last, which is 2, and twice the product, which is 4 √2. Squaring that puts it back to 2, so that gives me 8 plus 4 √2. So popping it into this, notice I want to divide that by 4, so that'll just be 2 plus √2. It'll be 1/8 of pi times 2 plus √2. Right, well that's the whole sector. Now what about this delta kite? What's the area of that? I'll just put AD for a delta kite. Well, the area of that shape will be half the product of the diagonals. Well, I know this diagonal is √2, so the problem then is, what's this diagonal here? Call that D1, call that D2. Because the area is going to be a half D1, D2. So it's a half of, well that one's √2. But what's this one here? Well, you could do Pythagoras in the centre bit, or you could just say, well, √2, the whole thing's symmetrical. If that, each of those sides is √2, so if this is a √2, then that must be a right angle. So if that's a √2, that must be a 1 and a 1. Do Pythagoras if you like. So that diagonal must be 1. So that's a half of √2 then for that part. So the area of the corner piece will be this minus that. So the area of all the corners will be 4 times this minus that. And of course 4 times that is going to be a half of pi, so pi upon 2 times 2 plus √2, and 4 times that going to be minus 2 √2, and there's your answer.